day 2 of our 3-day executive training programs on Python. Already yesterday we laid the groundwork, that is fundamentals of Python and NumPy. Today we shall start building on it and visualization of Python. In this session, that is technical session 3, Dr. Firod Sarkar is the coordinator. So I request Dr. Firod Sarkar to introduce our eminent speaker, Dr. Jayabrata Biswas. Sir, start your introduction.
Thank you, sir. Sir, am I audible?
Yes, yes.
Yes.
Okay. So it is my great privilege to introduce today's distinguished speaker, Dr. Jayabrata Biswas, Assistant Professor in the Department of Statistics at the University of Bardhaman. Dr. Biswas earned his PhD in statistics from ISI Kolkata, where his research focused on Bayesian linear mixed models for analyzing semi-continuous longitudinal outcomes. He also completed his M.Stat from ISI Chennai and his BSc in statistics from Ramakrishna Mission Residential College under the affiliation of Calcutta University. His research interests include longitudinal studies, zero inflated distributions, modeling with missing values, quantile regression, extreme value distribution, etc. He has contributed numerous research papers in reputed journals in the field of statistics. At the University of Bardhaman, Dr. Biswas is actively involved in teaching several advanced courses such as Python programming, time series analysis, multivariate techniques, mathematical analysis, etc. His technical expertise includes proficiency in Python, R, C, C++, LaTeX, uh, it is etc., which enriches his teaching with practical insights. Today, on the first lecture of the second day of this program, the 3-day executive training program on Python, jointly organized by Raja Anil Khan Women's College, Mednapur, in collaboration with Sridhar Acharya Academy of Mathematical Science, Mednapur, West Bengal. Dr. Biswas will deliver a talk on the topic data visualization in Python. This is highly relevant and a practical topic in the era of data science. We are indeed fortunate to have him with us for this session, and I am request to Dr. Biswas to deliver his valuable lecture.
Thank you very much. Is the slide visible?
Yes, sir.
Yes, sir.
Okay. Let's get started. So, hello everyone. My name is Dr. Jayabrata Biswas, and I'd like to thanks to the organizing committee for inviting me to deliver this lecture based on the topic called data visualization using Python. So, without any further ado, let's get started. So, first of all, introduce some statistical analysis, which is a fundamental technique for extracting meaningful insights from data, helping organizations make data-driven decisions and predictions. In modern era, exponential growth of data in various fields, including business, healthcare, and social sciences, has necessitated the use of powerful tools and languages to perform complex statistical computations more efficiently. Python, here comes the role of Python here. It is a versatile and easy to learn programming language, has become one of the most widely adopted tools for statistical analysis due to its rich ecosystem of libraries, flexibility, and integration capability. So, before going to discuss how to proceed with Python, let's describe some what is data representation. We already know that representing a data in several modes. The first mode is called textual representation. It is lengthy and traditional method, just like telling a story based on giving some information on the data. Just like land, how much land captured by agriculture and how much land captured by some living organism, etc., etc. The second one is tabular representation, which is more sophisticated analytic method. Most of us use this kind of representation for our statistical analysis purpose. And the third one is diagrammatic or graphical representation, which is visually appealing and attractive method. The main focus on this kind of representation is this: it is understandable for any layman, whereas textual or tabular representation, it is not understandable by any layman. You need some knowledge of the data for to understand this kind of representation, whereas diagrammatic or graphical representation, it doesn't need anything. So that is visually more appealing method. Here comes the role of data visualization. What is data visualization? Data visualization is graphical representation of data and information using visual elements like charts, graphs, maps, and dashboards. It helps people to understand complex data more easily by presenting it in a visual context, allowing patterns, trends, and outliers to be quickly identified. The main goal of data visualization is to communicate data clearly and effectively to both technical and non-technical audiences. It helps to making complex data more accessible and understandable, identifying trends, correlation, and anomalies which is present in the data. If it's present, then we can identify it by plotting the data, and supporting decision making through visual insights. In essence of data visualization transforms raw data into a visual context, turning number into a story. Data visualization using Python focuses on using Python libraries to create meaningful and visually appealing representation of data. It plays a crucial role in data analysis, helping to uncover patterns, trends, and outliers that are not obvious in raw data. So using Python for data visualization allows user to quickly explore and understand the data, identify trends and patterns, communicate results in a clear and more efficient way, automate and customize visual reportings. Whether you are a beginner or an experienced data scientist, visualizing data in Python opens up a vast array of opportunities for understanding complex problems and making informed decisions. So here are some basic Python libraries for how to implement data visualization based on these libraries. Some common used Python libraries for data visualization include Matplotlib, which is our main focus throughout this session, a basic and widely used library for creating static, animated, and interactive plots. It is a low-level graph plotting library, in that sense visualizing for utility. Seaborn, built on a top of Matplot library, it provides a higher level interface for creating visually appealing statistical graphics. Plotly, a library for interactive web-based visualizations that can be embedded in web applications. And Pandas, through primary for data manipulation, it has built-in plotting capabilities that integrate with Matplotlib. So I would like to say that these four libraries are not the only libraries for data visualization. There are many more, but Matplotlib, Seaborn are the most basic one. So we are going to learn using these kind of libraries. And there are different type of data representations are there. One of them is more widely used is line diagram for identifying the pattern of bivariate data, bar diagram for comparing quantities, scatter plot to show correlation or relationship between two bivariate data, pie diagram for showing proportions, histogram to show frequency distribution, heat map for correlation matrix or data density, multi-line plot for comparison purpose also, and many more like QQ quantile plots, or which is referred as QQ plot, whether the data coming from normal distribution or not based on the graphical plots. We can also understand that. That is how QQ plot works. Plot diagram that is more complex, etc. So here I will give you some examples after that the session. So let's get started. So I already instruct you to open your Jupyter library. Have you all opened your Jupyter library? Notebook, sorry, not library. Jupyter notebook.
All participants are requested to open your Jupyter library
Notebook.
as a notebook, sir. Yes,
Jupyter Notebook.
yes, yes.
Okay, okay, okay. I
Sound
already got a response from Bappa Noshkar. Yes. Okay. So let's get started here. So what I'm going to do, I write some code here. You try to write it and then see the results. I will explain the code. And after some time, I will give you the code in that chat box. Okay. So message box in the Google Meet. So you may copy the code and paste it in your Jupyter notebook, and then I will explain the code. Okay. So first of all, some basic versions are there. Let's get started. So you already have some fundamental ideas about uh, Python. So import is a key feature to calling a library, and our library name is matplotlib, and then press enter. And first we have to check what is the version of our matplotlib library. My version is relatively older than yours, so doesn't matter anything. But I hope all things are sorted out. Matplotlib dot underscore version underscore. Print. Oh, sorry, write it wrong. Version. VERS ION. Matplotlib. Okay, just keep it, and let's start some more thing. I think there is a mistake in there. Import matplotlib pyplot as plt and numpy as np. Sorry, I think there is two underscore. Yes, you have to give two underscore is there. Matplotlib underscore underscore version underscore underscore. That is our matplotlib version 3.1.3. And now matplotlib.pyplot as plt. We refer this submodule pyplot as plt, which is under the matplotlib library, and then import numpy also. Already imported it. Now I have to draw a line. Fine line diagram. HP, that is np dot array. I hope you are familiar with this kind of structure, np dot array. Np is coming from the numpy library, and array is array structure of numpy 1.8. np dot array, that is 3.10. Now here comes our first plot, plt, drawing a line diagram, dot plot xp yp, and now you have to show this by giving this comment, show. Have you got this graph?
Yes, sir,
So
it's visible.
okay. Now the idea is this: the how the graph works. XP is a point and YP is another point, but it is not 1,8 point. The point is actually 1,3 and 8,10. Okay. XP means the all coordinates coming from x-axis, and YP means the all coordinate coming from y-axis, and they tally one by one in this following order: that 1 comma 3 to 8 comma 10. That is our main point. So you all we can also understand this in this following way, that uh, plotting without any line, xp yp, that is small o. If you enter, you can see these are the 2 points. Okay, 1,3 and 8,10. So that is how we give the x coordinate and y coordinate values here. So now, how about plotting multiple points? Okay, so plotting multiple points. Three, three, 1, 2, 6, 8, yp, array 3816, 381, dot show. Now these are the points, and it's also a line diagram. But if you just want to see all those points, not the line diagram, then your comment should be this: plotting points without any lines. Is this xpyp, and this is o. That means just only saw all those points here, from there to here and here and here, and so on. So now plotting values without the x-axis, without mentioning x. yp in p dot array P811057 p dot plot. Just write here yp only. Yp LT. So see, this is the plot, and if you in previous case we saw that the this is the x-axis values and these are the y-axis values, but these are x-axis y-axis values. Here we here we do not mention the x-axis value, so it will take default values from 0 to 5 because there are 5 points are there. 1 2 3 4 6 points are there, so that is the 6th point actually. If you only see those points are there, then the comment is this, and these are the 6 points are there. So counting starts from 0. That's why it is end with 5 numbers. Otherwise, it will be a 6 values number. Okay. So now plotting multiple points, not multiple points. I mean, here comes the role of markers. YP already mentioned here, so we do not mention it here. Just write this code ELT dot plot YP marker. What is the role of marker? You already understand it here. What does marker actually what? Dot. These are the main syntax. See, the points have been changed with the star notation. If we use O, then it will be the O notation. If we use plus, there are different type of markers are there. Then each point will be treated as plus notation. If we use D, then point will be treated as diamond notation. So you can change it. For different markers, you have different type of points notation. Now, here comes the marker size. Marker size parameter is called ms parameter. ELT dot plot this, and now we try to increase the marker size, that is the MS say 10, then here if we show this, if we make it 20, then markers are big, and if we hide, then these are small, and so on. You can change the size of the points based on this particular parameter called marker size, which is abbreviated as MS, and write it in this inside of the PLT plot. You can write it. Now it's a marker edge color. Copy this code, paste it, save execution. MPC marker edge color, that is, if we write R, that means marker edge will be colored as red. So in this way, we set 15. 15. So if we write Y, then it will be yellow. Marker face color. MFC parameter. You can see the changes here. That is marker face. We write R, that means face color will be red, and so on. You can also mix these two things, that is MFC R and MEC is Y. This marker edge color is Y, or say green in G. You see, the edges are green. I think it's going to be easy to visualize. Edges are green. Setting both edge and face of the markers are red. I have to copy this code, paste it. We write G as R. This is big thing. All points should be colored as red. Now, here comes another thing. Line line style. List parameter. Plt dot plot yp list dot h. If we write it dashed, then you will see. Dash dot h. So in this way, you can change the line style also, and you can also uh, mix their convex combination. That is, if we put the marker there, you want to see those points, you can also add those things here. Now, there is another block. It's called dash dot. Here, this is the line which is dash dot h structure. Now, here is the line color. The arc. You want to see this. If we write is G, if we write it Y, then it will be a yellow line, and so on. These are the different line colors. A means black, background. Line edge. LW parameter. In 0.5. So if you change it to 0.5, we omit this, then you can see the ordinary line, end of line, and so on. Now we are going to plot multiple line on the same graph paper. Okay. The command is this: plt dot plot yp1 plt dot plot yp2 and plt dot show. See, these are the two lines. If you want to see those points on it, then write this. These are the points. And you can merge the above facts also here. So you want to change the line weight or something, color of the line, line structure, and so on. You can easily implement this in this plot section. Okay. Exactly. So x empty array 1, 2, 3, 4, 5, 6. X p2 we already mentioned yp1 or yp2 this above structure. So yp1 yp2 are same as this. So now the command is this: plot x p1 comma y p1 x p2 comma y p2 plt dot plot plt dot plot. Same structure starting from 0 to 5, starting from 1 to 6, because we already mentioned that x-axis is 1 to 6, and based on this x-axis they plot the graph that is known as multiple line diagram. Now adding labels to x and y axis. These are the two data points. You don't need to write it. I already sent. See the comment section, that section. I already sent you this structure. So just copy paste it and then write plt dot plot xp yp. plt dot x level, that is we are going to labels to x and y axis. X axis description, say plt y is x axis description, y axis description. You can write anything here. That is a string argument, so you can write anything. So describe the x axis values and y axis values and so on. That is the graph. If you want to see those points, then you can go here. That is the point, and you can also add different structure here. Okay, now title for the plot. How to create a title? So nothing but same as this. Copy and paste it. Add an extra line. plt dot title main title. Right, so that is the main title of the plot. You can also omit this point and plot this in this way. Now set properties. You can also set the font properties for the title and labels also. The data sets are remain same. Just create two dictionary in this following way. Font 1 and font 2. And now copy paste this. add here font height is equal to font 1, copy this, paste it, say 2, paste it, say 2. See, fonts have been changed, the color also changed. In this way, you can change the title, the I mean x-axis levels and y-axis levels of the graph also. Now, here comes the position of the so uh, log parameter. We can change the position of the main title. There are three possibilities. One is left, another is right, and the third one is center, which is by default choice. So I write it right. Main title is the left. If we write it left, main title is in the left corner. If we center by default choice. So in this way, we change position of the main title of the graph. Now, adding grid lines. Paste it, and before showing, write plt grid. So you see there is a grid lines here. In this way, you can add the grid lines on the plot. Specific grid line display. So same as this, just write axis. You want to see only x-axis, not y-axis, then only x-axis. Want to see on the y-axis, not x-axis, then the same position, write y to y-axis. If it doesn't write anything, then by default it will show the both grid for x and y-axis. Grid line properties. marker is plus. So copy this, paste it, title, main title. You can also set the color of the grid line. CO color, say green. I want to grid line as green. See the green color grid line. Line style. Dash dot line style here, and line white LW L8. Is that the line white? You can change the grid line, structure of the grid line also in this. Now, display multiple plots. Row-wise distribution. Plot 1. And plt dot plot one, two, one. Plot 1, 2, 2. P dot plot x p1 y p1 p dot plot x p2 comma y p2 and plt show. These are the two graphs they are showing. Here I would like to say that the subplot function takes 3 arguments here, 1, 2, 2 and 1, 2, 3. That describes the layout of the figure. The layout, actually this is the layout of the figure. The 3 components are actually row number, column number and figure number. The first one is known as the row number, second one is known as the column number, and third one is the figure number. So layout organized in row, columns, and which are represented by the first and second argument. And the third one is called the index of the current plot. So this P1 is the first one, X P1, Y P1 is the first plot. So This is the first plot, and this 2 represents the second plot. So this is the second plot. And we can also display the same plot column wise distribution also possible. Just write in this way. Same. Copy this and paste it. Column wise distribution. So it means there are 2 columns, not 2 columns, 1 columns and 2 rows. So that is 2, 1, 2 rows, 2, 1. And now plot this. See, this is represented as column wise graph, and this is row wise. We can also extend this for 6 plots also. I already just copy this code and paste it. See, these are the figures. I already send you. So if we want to hide the x-axis and hide the y-axis, then this is the command tlt xtx this. So if you do not want to hide the x or y-axis, then just hash this. In this way, we can plot multiple plots in the same graph. So the command is subplot. Okay. So now, if you are wondering that how do I know what are the marker signs and how do I know what kind of line structure is this? I already give you some of the hints, but there is a command. In this way, you can already know how to help. Matplotly dot py plot dot plot. See, here you will get the documentation of what are the possible symbols for the markers. These are the possible marker symbols. They are the markers. Some of them are already used. Some of them already have not. So you can try it. There is a line style structure. These are the format of string. There are some of the what kind of color we are going to use. B for blue, G for green, etc. etc. So in this way, we can get more deep into this line diagram structure. This is the title and subtitle structure of any graph. Just write PLT title, subplot 1 title, subplot 2 title. That's it. Subplot 1 title, subplot 2 title. The ultimate title is this. And add the main title also here. This is the main title. It's known as PLT soup title. Now, here we are going to create some scatter plot. Code. This is scatter plot code. So think that there are 13 cars are there, and these are the ages of the cars, and these are their speed limits when they are passing in a speedometer. So we want to check. We have another 15 observations already in our hand. So if you want to check whether there is any correlation exist or not, comparison day 1 the age and speed of 13 cars, that is this we already see here, and day 2 is the second day, we already have 15 observations, and we want to check whether there is exist any correlation about the age and speed limit of the cars or not. Sorry. See, more or less there looks like almost same. These are the codes. Don't. Okay. Changing the marker color of the above plot. You can also change the marker color. These are the comments. You can also change the marker color. Color change to red, and this is changed to green. Don't write it PLT show. Now, this is how we draw the scatter plot. Now we are going to create bar diagram. These are the code. X is the whatever it is called the string elements and y is the values. And we want to create a bar diagram. It looks like this. And if you want to plot a horizontal bar diagram, then the code is this. This is the horizontal bar diagram. Just simply write instead of bar of H. H stands for horizontal. Then you can easily find out what the bar diagrams looks like horizontally. You can change the bar color. This bar height, and change it. Point 0.5 looks like this. 1.5 looks like this. And so on. Now we can also plot a multiple bar diagram. This is one example. So number of girls and boys, there are 3 groups are there. Each group contains some number of girls and boys. This is the information, and we want to see this in a graphical representative way. To plot this is known as multiple bar diagram. Okay. There is another example called number of men and women voted in a particular year. This 2018 to 2021. These are the examples. And 2018 to 2021. You can also see this is the bar diagram looks like. So now we are going to drawing a pie chart based on the data. This is called PLT pie, and Y is the data, and A is the string elements. So if you want to see the string elements inside the plot, then code is this. We show the labels here. We can rotate the pie by the angle of 90 degrees. This following one. Start angle 90 degree. So 90 degree rotation. You change it. accordingly. There are some more fancy things, like we are going to explode a particular structure. Say we are going to explode uh, 1, 2, 3, 4, 5, say E, A, B, C, D, E. We are going to explode E. Then the code is this. Sorry, not E, B. 1, 2, 3, 0.15. Yes, D. Sometimes we are going to highlight something in our pie diagram. Then we can explore this particular structure in this following code, based on the following code. And that's with legends. Is an interesting thing. You can see legends will show you what color represent what, the different grades and so on. And we can also draw some card. This is the code drawing a sine curve. See? With no axis values, if we write this thing, line diagram with no x-axis values. And I would like to end this particular discussion by drawing a continuous type data, drawing a ogive. This is the code. Okay, so this is the data. These are the class intervals. Calculating the frequency and class interval based on this NP histogram, data, bins, class interval, etc. Calculating cumulative sums. This is the code for reverse cumulative sum. Means one is called more than type frequency, one is called less than type frequency, and we are going to draw the graphs from more than type frequency and less than type frequency. Base will give you the initial plots, and then see the ogive graph. Ogive, this looks like this. I'll share you the code here. So I think that's it for different type of graphs. That helps us to give you the idea about how to draw different type of graphs and how to manipulate those graphs, how to change their layout, and so on, so on. These are the initial things, and I have some whatever is called some questions for you. These are some examples. You have to, so please draw a graph based on this particular question. Do you have any question?
Yes, sir.
Yes,
Sir, I have a question.
Okay.
Sir, actually, you have drawn so many graphs and in your research paper, and just I have got this graph, and how can I this graph to the our paper? How can I reshape it?
Okay, so you want to save that graph, right?
Yes,
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 sir.
yes.
How to say
Okay.
that?
Very good question. There is a comment. There is a comment called save the graph. Just wait. Uh, okay. So the comment is this. To save the figure in normal resolution, this is the comment. Okay. So whatever it's called. Sorry. Ojive. And you have to write it here. So instead of showing the plot, you are going to save that plot. And the plot will save where your, what is called the, this particular, the Jupyter notebook already held this kind of stuff. Okay. So your Jupyter notebook have this data visualization type of thing. I mean, you already, what is it called? You already saved your works somewhere in your computer, and you have to save it in this following comment. And there is another comment. If you want to save that graph in high resolution, then the comment is this.
Okay, sir. I have one question.
Okay.
Sir, actually, after obtaining any graph or figure, can I edit manually this type of figure as like a MATLAB figure?
No, no, no. You cannot edit it.
Oh, okay.
You have to edit it based on the code.
Achha.
Okay.
Okay.
So whenever you are input the data,
Yes.
based on the data, you can change the data, and then accordingly your graph will be changed. But you cannot edit it manually.
Okay.
Within the graph. You cannot do it.
Any other question from the participant? Any question from the participant?
Hello.
Yes.
Yes, yes.
Thank you, sir, for this presentation. It was really good for us. Sir, could you please share this code with us so that we can practice in home?
Yes, I can share it with you. But you have to open your Jupyter notebook and write it down, right?
Okay.
I can share it with you. It doesn't have any.
Thank you.
Any question?
And I have some problems in my slides. I can also share it with you. These are some examples. Is it visible? Is the slide visible? Yes.
Yes.
This is the example one. You can draw it, whatever the picture you would like for the particular problem. And
Sir, I have a doubt, sir.
yes.
Sir, the graphs that were shown to us were, when all of them were mostly two-dimensional plots. So,
Yes.
is there a provision of drawing three-dimensional graphs also?
Yes, you can also draw three-dimensional plot, but that will require a more programming knowledge. These are very basic things.
Okay.
So for higher dimension, you need some more technical knowledge. Yeah. And I would also like to say that you can also animate your plot, okay, based on matplotlib library. But again, that needs more technical skills. You have to know the knowledge of how to create functions, how does whatever it is called, array works, and the range works, etc., etc. Then for loop works.
So, sir, any references for learning 3D plots and something like that, sir?
You can visit the whatever it's called Matplotlib library. You can
Okay, sir.
also see some 3D plots there.
Okay, sir. Okay, sir.
Those are also basics, but it needs some technical skills for Python.
Okay, sir. Thank you, sir.
Okay. So these are example 2, and this is example 3, and it's example 4. You can draw it uh, whenever you want to. Yes. So that's it.
Okay,
I can
sir.
share the slide with you also. It doesn't.
And I think, okay, is there any question from the participant? Okay, I think there is no question. And thank you, sir, for delivering such insightful, valuable lectures on data visualization in Python. You have discussed about different topics like scatter plot, line plot, bar diagram, pie chart, etc. Your clear explanation with a practical demonstration made the session very engaging and valuable. Thank you once again for sharing your experience and a valuable time with us. Thank you, sir.
Thank you. Thank you.
So 1 minute, 1 minute. So a token of appreciation. I'm showing the certificate of your appreciation, certificate of appreciation for delivering such a wonderful lecture. Yes. Okay. So I'm showing in that screen what I will see the certificate by them. Okay, sir. This is the certificate. So, oh, sorry. No, sorry, peanut. Jayabrata. This is the Jayabrata certificate.
Thank you,
Is
sir.
it visible? Yes,
Yes,
sir.
yes, yes. Thank you very much.
I send the certificate to your email ID. Okay.
Okay. Thank you.
Okay. Thank you very much. Thank you, sir. Thank you, Dr. Khilot Sarkar, and thank you all participants. But this is the perfect time to grab some lunch and recharge. So we shall come back after 30 minutes. That is at 1:30.